Hi everybody, I'm Scott Stewart with the University of Tennessee, and I'm going to talk today about some insect management issues, and you'll also hear from Jessica Krob, who's a master's student with me now. And we're standing in front of a bunch of thrips trial work that was done in Jackson, Tennessee. Actually, our honey hole this year for getting thrips data was in Milan, Tennessee, where we had much higher pressure. And I'm going to talk today about the big three cotton insect pests that we deal with. And of course, there's a number of minor pests or more occasional pests that we deal with. But when I say big three, we're starting off with thrips, then we're talking about tarnished plant bug, which is consistently our most important pest, and then cotton bollworm, which is more towards the end of the season and a pretty significant pest. And you may see me look down at a sheet of paper because I have some notes, but as we go through this presentation, instead of seeing posters, you're going to see some PowerPoint slides that support some of the points I'm going to make. One of the first things you're going to see is the results of a foliar insecticide trial designed to look at control of thrips. And the data that you're going to see is thrips injury rating data. This data was collected at Milan, Tennessee this year. Again, we had some very significant insect pressure, and I want to make a couple of points off that data slide. First thing I want to say though is describe what you're looking at. You're looking at a bar chart with various different foliar insecticide applications, and the rates are indicated on those bars as well. And what it is it's essentially an injury rating. And most entomologists rate thrips injury on a 0 to 5 scale, 0 being no injury and a 5 being very devastating injury. And in fact, really it would mean all the plants in the plot were dead. So if you look at this bar chart, you're going to see that where we didn't have an insecticide seed treatment, the check, or where we just used a pyrethroid insecticide, we had very intense injury ratings well above 4. And in a minute, you'll see what that looks like under field conditions. Our two best treatments in this test were products known as Intrepid Edge or Radiant. And they're really the same product in that they have the same active ingredient that's controlling thrips, spinetoram. That product for the last several years in Tennessee has been more consistent at controlling thrips in seedling cotton than acephate, which is our longtime standard. And we'll kind of circle back to that. By no means does that mean acephate's not working well, but we are suspicious that we're seeing some resistance issues. One thing we are seeing in these tests, we have two different rates of acephate. We have acephate at 1/4 pound, which is pretty much a standard rate, and then we have a 1/2 pound of acephate per acre in there. And we do see a response. There's a little better control with the, or less injury, I guess you'd say, with the higher rate of acephate. Now, as you switch images, the next thing you're going to see is a drone image of this test, and it's a pretty impressive drone image. On the left side of the image, what you're going to see is border rows, and there's 4 border rows planted there that don't have anything on them but a fungicide seed treatment. And what you really see is pretty much bare soil. So that tells you how intensive or how intense our thrips pressure was at this location. As you look out across the plot area, you're going to see some labeling on there. CHK indicates check, the PYR indicates the pyrethroid. Those two plots are very evident in that picture, very sparse populations, because the thrips actually killed the plants in those plots. For the most part, the other treatments look more or less similar, at least from a distance, but again, the Intrepid Edge, labeled IE on that, or the Radiant plots were a little bit better. This, by the way, I mentioned we had a thrips rating scale of 0 to 5, and our check plots are rating a 4.3, 4.4. That's what that looks like. We've been seeing some issues, and it's been localized issues in the Mid-South, and seems to be centered worse in West Tennessee with resistance in tobacco thrips populations. And I'm not talking about neonicotinoid resistance, which we know about, that tobacco thrips have resistance to thiamethoxam and to some extent imidacloprid. I'm talking about resistance to foliar sprays, and what we've seen is inconsistent control with acephate in the last several years. And so I'm going to throw it over to Jessica Krob now, because that's part of her master's research, is to investigate acephate resistance and other pesticide resistance in tobacco thrips populations.
Thank you, Dr. Stewart, for introducing me. My name is Jessica Krob. I'm a master's student here at University of Tennessee, and like he said, I am looking at resistance to different foliar insecticides, and we are really looking at acephate resistance. I'm doing all of that work in the lab different states are doing the same foliar test that we're doing here, and they have sent me thrips populations. So we are going to compare the data that we've collected from the field and the thrips visual injury ratings to what our bioassay results show. And you'll see a PowerPoint slide kind of displaying our treatments. We had an insecticide treatment, and we also had plots without an insecticide treatment. In addition to that, we had 4 different seeding rates. We had 2, 4, and 8, and 16 seeds per foot. And the goal with that was to see how our thrips injury ratings were between these different seed treatments. And what we saw is that the higher seeding rate had less thrips injury rating compared to our lower seeding rate with 2 seeds per foot had way higher seeding rate. So we didn't have thrips numbers that really explained why our visual injury ratings were so different, but we definitely know that there is something going on there. The other data that we collected was in Milan. We had the same experiment, and you'll have another slide pop up showing the seed treatments with and without a seed treatment. And we also looked at plants that were clumped together versus plants that were isolated. So the way we did this was we took about an 8 centimeter length in our 16 seeds per foot plots, which really ended up being more like 6 seeds per foot because we had poor emergence there. But what we saw is plants that were clumped, they had less thrips injury ratings compared to the plants that were isolated. And one component of this, we think maybe why that happened, is the seed treatment between plants that are clumped together is being shared more between those plants versus plants that are more isolated and separate from each other. They're not getting that extra protection. Other things that could possibly be the reason for this is just more protection when you have a clump from sand blows and different environmental problems that could go along with that. And next year we are going to look at more of a hill drop scenario because we see this clumped and isolated differences within our visual injury ratings. So that's the plan for next year, and I'll also continue looking at the insecticide resistance to different foliar insecticides. And with that, I'll hand it over back to Dr. Stewart.
So Jessica's kind of continuing with some work that we started prior to her getting here, and we're definitely seeing some issues in some areas with acephate resistance. Obviously we have pyrethroid resistance, and you could see that in the data as well, but they're very different because acephate's still providing some control, and again, higher rates I'd say are probably going to be adequate in a lot of cases. So we're really trying to chase that down. It's something that's not being seen everywhere in the cotton belt, but it is seemingly getting a little more widespread. So that's interesting. Now, the plant density stuff is of personal interest to me because I've noticed that over the years that when we get into thinner plant stands, I see more thrips injury, and I wasn't sure if it was my imagination or not. And I think Jessica's data clearly shows plant stand matters. Now, obviously we're not going to plant 16 plants per foot or even 8 plants per foot. We can't afford to do that. But I think we can take advantage of how we plant, whether the plants are more uniformly spaced or maybe you do a hill drop like she mentioned with 2-3 seeds in a hill and reduce thrips injury. So we talked a lot about thrips control. I do want to mention a couple of things that are, well, really one thing that's coming down the pike, and that's the new Thrive On technology that's being developed by Bear Crop Science. And you'll see a drone picture of some plots I have in Milan, Tennessee. This Thrive On technology is the technology I've talked about before that has activity on thrips, but also tarnished plant bug. And as you look at that image, that's an image of a regulated test plot. So this technology is not available yet. And if I remember correctly, there's a box around all the Thrive On cotton. If it doesn't have a box around it, it doesn't have that trait. And if you look at that image, it's actually pretty obvious where we have the Thrive On technology, because those plots tend to be quite a bit more vigorous. You don't see as much ground in those plots, and most of that is because of tobacco thrips. We had very severe tobacco thrips infestations, again, in that myelin location. Even though all those plots had an insecticide seed treatment on it, an insecticide seed treatment wasn't enough to prevent thrips injury. So that's encouraging. We might see some of that being introduced into the market in the next year or two. That technology, as I mentioned, also has activity on Lygus. Lygus is the generic or genus name of tarnished plant bug. It's exceptionally good at controlling tobacco thrips. We've really seen no chinks in the armor. It definitely helps with management of tarnished plant bug, but it's not the kind of technology you can just assume you're not going to have to spray. In fact, that's not the case. And what our data is showing this year is we're seeing about a 40% reduction of Lygus populations in that Thrive On technology. And where we're managing those populations, we've actually saved about 1 insecticide application on the technology versus where we don't have the technology. Of course, we'll take yield data in those plots. It's kind of interesting to me, now that we're getting closer to market with this technology, we're testing it in larger plots. It looks like what we're seeing in larger plots is maybe a little better than what we're seeing in smaller plots. I suspect I know why. My previous graduate student, PhD student, Scott Graham, did work, and his data showed that this technology was really repellent to tobacco thrips, and at least part of the activity on tarnished plant bug was repellency. So I think as we get into these larger blocks, it makes it a little easier for insects to avoid it as opposed to having small plots, and we'll see how it goes when we get on a commercial scale. But I think it's very encouraging because it is going to save insecticide applications for our growers. I'm going to switch gears now and kind of finish off with just a few comments about the other pests. I've already mentioned tarnished plant bug. That's a primary focus of our research program that we work on year in and year out, and there's a whole bunch of things that we research, but really the core of our tarnished plant bug management program is based on insecticides. We can do other things to minimize tarnished plant bugs, but we still are pretty heavily reliant on using insecticide applications. You'll see a slide on the screen that shows you a result of an insecticide trial. That insecticide trial is something that's done throughout the Mid-South by my counterparts and I, and we've done it for a number of years. It really includes all the active ingredients that we could potentially recommend on tarnished plant bug, and there's really no surprises there. What that graph is, it's a cumulative number of tarnished plant bugs that we found across 3 different rating dates, and the best 3 or 4 products on that list are the ones, of course, that have the fewest number of plant bugs. And every year, year in and year out for the last several years, there's been 3 products that rise to the top. One of those is Transform, the other product is Orthene, and the third product is Diamond. So I always tell people, if you call me in July and August with plant bug questions and wanting to know what you're going to spray, a lot of times you're going to hear me talk about those 3 products, and they may be applied in rotation or in combination depending on what's going in the field. But we have consistent pressure here at the station, so it's a good place to do research. Very typically in our trials, if we don't manage tarnished plant bug, we can lose 300 or 400 pounds. Sometimes it may be 100 pounds of lint, sometimes it may be 2 bales of lint, just depending on how severe the circumstance is. So it is a major pest for us. I'm going to end by talking about bollworm. That's the end of the big 3, the third of the big 3, and we're right in the midst of collecting data on bollworm in cotton. So a lot of our trials are similar to plant bug. We have a number of tests where we're looking at different insecticide options for controlling bollworm. We do most of those tests on non-BT cotton so that we get higher populations. And then we have a number of tests where we do evaluations of the BT technologies that are out there to control the bollworm. I think on your screen you will see a test where we've actually got all the current BT technologies that are being sold, and those technologies have either been sprayed or not sprayed with Prevathon, which is a very good diamide insecticide for controlling bollworm. The point of that slide is the newer BT technologies, particularly the Wide Strike 3s, the Bollgard 3s, and the Twin Link Pluses, do an excellent job of controlling our caterpillar pest, including bollworm. And in fact, in our ratings so far this year, which have just started, we haven't even seen damage in those plots. We'll see a little bit of damage in the Bollgard 2 technology, and that tends to intensify or get a little bit worse as the cotton progresses. So we're starting to see that right now. And the big bar that you'll see on the screen is fruit damage in the non-BT cotton. And if you look on the graph, what you'll see is if we don't have an insecticide application, in this case 2 applications of Previthon, we saw about 25% fruit damage in those plots. Where we made the 2 applications of Previthon, we essentially have zeroed out fruit damage and done a very good job of insect control. So in this case, we're kind of evaluating the technologies and the effectiveness of the Previthon application. This is another example of a regional trial we do across the Mid-South, and really we do this continuously to try to get a sense for how well these technologies are holding up over time, whether we're seeing changes in the performance not only of insecticides but also of the BT traits, because we are worried about resistance, and we know we in fact have some insecticide resistance to the BT technologies and the foliar insecticide applications. So that's going to bring me to the end of my presentation. I think really the take-home point is, there's a lot of things we do have to think about in cotton. There's no doubt that cotton insect management is more intensive, or insect management in cotton is more intensive than in other crops, but it is manageable. We have some very good insecticides. We have some good technologies that we can keep things under control. It's just a matter of making those management decisions and choosing the right management decisions at the right time. And that's, of course, what we're trying to do in my research program.